Hello, this course is going to focus on analysis and design of embankment systems, earth embankment systems. We have different types of earth embankment systems in civil engineering. We use it as earth embankment dams for water storage, as earth embankment dikes or levees, or as tailing embankments for storing mine tailing materials. Also, the knowledge that we will learn through this course, it will be helpful for analyzing and designing slopes, natural and man-made slopes as well. So we have different types of embankment systems in practice. For example, in this case, we have an earth embankment made of rock-fill materials for water storage. We also more commonly use different types of soil materials in different configuration systems to build earth embankment dams, as you see in the right picture here again, for storing water again behind them. We use embankment systems in the form of tailing dams for storing tailing, which is mined waste materials behind them. And eventually earth embankments are also used in design and construction of roads and highways and other types of applications, railways as well. So proper analysis and design of these embankment systems need proper understanding of geotechnical behavior of the materials that we have underneath these embankments, as well as the materials that we use as a construction materials in these embankment systems. Without having that proper understanding, we might end up having failure in the embankment systems, like in the examples that you see here in this case for earth embankment dams, or other types of failures, failure in tailing dams, as you see in this picture. We may also have failure in road systems and railway systems if we don't have proper understandings of the behavior of the materials that we use within and around these embankment systems, as you see here in these examples. So the background geotechnical knowledge here normally starts with site investigation. This is applicable to any civil engineering project. We start exploring the site that we're going to place our project over there, because without having a good understanding of what's going on underneath the ground surface over there, we might have problems like this one here. This is caused by fault rupture, which it was over there underneath this project. So from structural or transportation engineering perspective, there was no problem of these two structures that you see here. We may also have problems like this one, which is known as liquefaction, which happens in sandy soils. We're going to discuss about it when where we are in earthquake prone area. Liquefaction also could collapse and fail or cause damage to different types of infrastructure systems. So the white pictures that you see here, which are moving down, these are structures above ground over there, or embankments or roads or whatever infrastructure systems that we have, which happen because of liquefaction. So through process of site investigation, which we can get it using geophysical survey like this one, or geotechnical drilling like this one, we are able to understand what's going on underneath ground over there, and using those data we are able to design these embankment systems. One of the applications that these data will give us, it's how to design these embankment systems in waterfront applications, like in dams, like in tailing applications. So water flow through these embankments will be governed by behavior of the soil, which we name it as permeability coefficient or hydraulic conductivity. So by identifying those properties, we will be able to perform this seepage analysis, as you see, to see how much we can control, minimize flow of water. Another application in embankment design will be checking stability of the slopes that we have on either sides of the embankment. And again, we will need those basic soil data, shear strength parameters that we can use to get the slope stability analysis to be done. Sometimes we will see interaction between these flow of water and that slope stability analysis, as you see here, in rapid drawdown of these reservoirs behind these embankment systems. Okay. So This course is designed to provide those background knowledge as well as practically how we analyze and design those embankments. It will be distributed the material through this course over 6 weeks, and in each week we're going to start from the scratch and we're going to end try to reach the embankment design stages. So the first week will cover mostly the basic information we need for embankment design, which includes index properties of ground materials, how we quantify ground materials, looking at different size of soils and see in which portion of embankments we can use fine grained soils, coarse grained soils, and their behavior and performance. In the second week, we will look at how we compact these earth materials. As you know, in embankment design, we compact the soil to increase their strength as well as to decrease their permeability. So in this week, we will learn what water content should we add to the soil to be mixed, and how should we compact it, and also how we can measure the degree of compaction. Obviously, by not doing proper compaction, we will have problems like this one in road construction or other applications. Also, we will learn about dynamic compaction for other natural soils if we need to compact it under embankments. In the third week, we will look at flow of water through the soil. So using this background knowledge and understanding, we will be able to quantify flow of water through embankments. This is known as seepage analysis. We will do this seepage analysis by hand calculation as well as using computer program. We will be using CPW in this case. In the fourth week, we will look at stress distribution within the soil. We will talk about basic stresses as well as effective stress. The knowledge that we learn here, it will help us to understand the implication of flow of water through the soil and how we can prevent failures like this one, which is known as piping failure. In the fifth week, we will look at failure in the soil materials to understand how the soil fails and how we can predict such failure and how we can measure resistance of ground materials against such failure using lab testing as well as field tests. The results that we learned, the knowledge that we learn in this week will be used in the next week for slope stability analysis of embankments. The shape of the embankment and its slope angle of it, it's defined by this slope stability analysis. Here we will look at the hand calculation as well as using computer program SlopeW for performing these analyses. The knowledge we learn here will be also applicable to checking stability of other natural slopes or man-made slopes, and we will be able to check stability of any other slope conditions under both static loading as well as seismic loading. So this is introduction of this course, and now I'm going to take you to a brief tour of looking at one of these earth embankment dams to see how we choose the location for it and where we place it. This is in Western Canada, and as you see here, we're trying to find a proper location, place an embankment over there to store part of water behind this embankment to minimize the risk of flooding that we have in the city of Calgary in Canada. So this shows a typical earth embankment dam. In the upstream side, we have a layer of riprap to minimize erosion. This is the left side shows the location of the spillway and other components of the earth embankment dam. So thank you so much for your attention, and I hope to see you in the course. Thank you.